Hi, my name is Evgeny Skvortsov, and this is demo of Logical Robots. Logical Robots is an interactive system that simulates swarm of robots where you write program for your robots in Logica. Logica is a modern logic programming language that enriches classic programming syntax with nice features, including aggregation and functions. We hope that Logical Robot Sandbox attracts attention of both robotics researchers and logic programming community. Elegance of Logica allows describing reactive behavior as well as long-term planning seamlessly in a unified fashion. We hope it is useful for robotic researchers and enthusiasts to refine and explain their ideas. And using Logica to program little robots, see them achieve the goals, can be an exciting way to learn and practice logic programming. Here is UI of logical robots. And in this sandbox, we can just click the debug button and open into program editing mode, where we can see the table that your program has access to. We can see the name of the robot on this level there. This is a simple level. We just need the robot to go forward. So we just turn both engines to full throttle to 1. And it's an easy way to success. Let's look at a slightly more advanced level. Here again, we have only one robot, but we need to avoid the walls. And here we can see how we can use aggregation to make the robot follow into the direction where we have the most open space. We don't have time to go into details of the logic programs here, but I hope you can see the elegance. And this is the first view of the robot, where we just see what the robot sees, which is their sensor reading, and that is how they make their decisions. In this level, the robots want to go to that sweet spot in the middle. And luckily, there are these breadcrumbs that can help them follow there. They are lexicographically ordered. So the program that you just saw just uses argmax aggregation function to have the robot follow into the direction of the beacon that is closest to the target. And they keep following until they see a beacon that is even closer. On this level, robots behave almost identically, but you can differentiate. And here we can send one robot to the plumbing station to turn off the flood. Another robot already went to the fire station to turn off the fire. And now the mining robot can proceed to the mine safely and achieve victory. You can have a lot of fun programming reactive behavior. This robot, see how it positions itself accurately right between the beacons to achieve the goal. Robots have memory. So here we see the program where the robot knows its loneliness, how long ago did it see its friends. And if loneliness is just above 0, so that if they just lost their friends, you can see how they start spinning and to find each other. So this way they can get into the formation and proceed all together to the winning area. The blue robot is the leader. So leader doesn't spin, leader stoically goes forward, and then they wander around closely until they reach the victory. This is the most sophisticated level that we have so far in our system. This is a labyrinth where robots need to get to the yellow home area. And there are enough beacons, but beacons are randomly named. So when the robot sees the beacon, they don't know whether they should go towards or against it. But luckily, robots have telepathy. They can read each other's memory. So when robot sees a pair of beacons, they can report to the leader. They can use the sensors to compute and measure the distance between them, report to the leader that these beacons are near to each other, and then robots use classic declarative programming graph analysis algorithm to find path to victory. Logical robots comes with the levels editor. So once you explored existing levels enough, or if you just want to study some certain situation, you can create your own level. You can create the labyrinth. You can place robot, beacons, areas, and explore on your own. I hope the system interests you, and see you at the Logical Robots. Thank you.